So I'm Sean Green. I'm an assistant professor here at the University of Wisconsin-Madison in psychology. I'm also an affiliate member of the Games Learning Society. And my research focuses on how to teach people to perform perceptual or cognitive tasks better. And so this is important in cases where, say, people have suffered a stroke and suddenly their visual system is impaired. You need to rehabilitate them. Or it can be important in cases where people have jobs that require different types of visual skills. So for instance, endoscopic surgeons need very different types of visual skills than your day-to-day person, same with, say, an Air Force pilot. And so the question is how can we improve someone's visual capacity or their attentional capacity or their cognitive capacity? And so what we know from 30, 50 years of research, maybe even 100 years of research, is that humans are really great learners in kind of visual tasks. You give, say, an undergraduate $10 an hour, you sit them in a lab, and they're going to get better at basically anything you train them on. But what we found is that subjects only get better at exactly what you train them on. So just to give a very quick example of this, there's a very well-known task in visual training. It's called the Bernier Acuity task. And your job as a subject is very simple. You see two lines, kind of one on top of the other, and your job is to say whether one of these lines is offset, whether the top line is offset to the right or the left of the bottom one. It's conceptually very, very simple. So if you see this, from your perspective, you have to say, well, this line on the bottom is offset to the left of the top line. However, we can make this kind of arbitrarily difficult. The closer and closer we put the lines together, we can make it very difficult until at some point you can no longer actually figure out what the answer is. But we can train you to get better at this task. And so there's actually a Guinness Book of World Records that is held by a colleague at UC Berkeley, where he can actually tell the difference between a line that's offset a little bit less than 1 second of arc to the right or to the left. So people can improve their visual systems to really kind of outstanding levels. However, what we found is that all people get good at is the exact task that they're trained on. So if you're trained on doing this task where the lines are vertically aligned and you have to say, is this to the left or to the right, you can get very, very good at it. But if we make a minor change, we just reorient the line so now they're horizontal, and now you have to say, is this above or below this line over here? You basically start all the way back over. Everything that you improved at in doing the vertical lines, all we do is rotate them 90 degrees, and everything has to start all over again. You'll see similar effects. You can train someone to have very good vision over on the right side of space, give them lots and lots of experience, they'll get good at it. However, if you then put the same stimulus on the left side, they have to start over. And this is something that we see in cognitive training as well. So for instance, there's a very classic study wherein researchers looked at the memory ability of chess experts. And so what they did is they showed them a chessboard with pieces on the board, took it away after a very brief glimpse, and then asked them to recall where the pieces were on the board. And so what they found is that chess experts could remember on the order of 14 or 16 pieces more than your naive non-chess player. And so this was initially thought, well, playing chess increases your memory abilities. But what they later found is that, well, if you put those chess pieces down on a regular chessboard in some random order, rather than an order that looks like a real chess game, chess experts don't actually do any better. Their advantage is very specific to the board looking like a regular chess game. If you change it so it doesn't look like a chess game anymore, they have no advantage. And so these kind of findings are together known as the Curse of Specificity. It's again the idea that we can teach people to become very good at certain visual tasks, but that's all they get good at. They show no transfer of learning to other types of even seemingly similar tasks. And so this is practically pretty relevant, because again, if you think about the examples I gave at the beginning, something like an Air Force pilot, it's not going to do them any good if they've learned to do a visual task, well, only on the right side of space. Or an endoscopic surgeon, well, he's good at certain types of visual things, but as soon as you change it in a little tiny way, all his advantages go away. What you really need in these cases are training regimens that produce generally better vision. And so this is actually where we started looking at certain types of video games.